Joyita Thakur, extend a warm welcome to our chief guest, Professor D.P. Sarkar, our esteemed principal, Professor Shiv Kumar Sehdev. Hopefully he may join us soon. Our keynote speaker of the day, Dr. Anil Kancha, and our dear participants. We welcome you to the inaugural session of the 3-day workshop on green synthesis of nanoparticles and their biomedical applications, organized under the aegis of DPT-sponsored Star College Scheme, Government of India. We all know from the name itself that a nanoparticle is a very small particle that ranges between 1 to 100 nanometers in size, and the technology is used to create such small particles and conduct research on them is known as nanotechnology. But nanoparticles actually exist in the natural world as well and are also created as a result of human activities. Because of their submicroscopic size, they have unique material characteristics, and the manufactured nanoparticles find practical applications in a variety of areas, including medicine, engineering, catalysis, and environmental remediation. And when these nanoparticles are made by green technology, they become vastly superior to those that are manufactured with physical and chemical methods, as the green techniques eliminate the use of expensive chemicals, consume less energy, and generate environmentally benign products and byproducts. Our workshop aims to introduce the participants regarding the methodologies of green synthesis of nanoparticles and their characterization techniques and biomedical applications. During this 3-day workshop, the participants will also learn to synthesize nanomaterials using reagents and equipments commonly available in the lab. Since our esteemed principal, sir, Professor Shiv Kumar Sehdev, has not been able to join us, but I'm sure his best wishes are with us, and his constant motivation enables us to forge ahead in achieving excellence. So now I would like to invite Professor Darshan Malik, the coordinator of the Star College Scheme, Shivaji College, to share her thoughts with us. Ma'am, over to you.
Thank you, Dr. Jaita. Good afternoon, everyone. And on behalf of all the teachers of all the departments under Star College Scheme, I heartily welcome Professor D.P. Sarkar, Department of Biochemistry, University of Delhi, and of course, Professor Shiv Kumar Sehdev, the principal of our college. He's not there, and maybe he'll join us soon. And our esteemed keynote speaker, Dr. Anil Kancha from Bhagalpur University, and all the participants participating in this workshop on green synthesis of nanoparticles and their biomedical applications, which is being organized under the Star College Scheme. Well, I would just like to add here, unofficially, Professor Sarkar has been our guide as well as mentor, and he's always there to help us. Sir, I really express my deep gratitude to you to have accepted this invite and taken out your precious time to motivate the teachers. Your presence is always very motivating and very, very encouraging for all of us. Well, under this scheme, we have organized a number of activities for the students, like summer training programs, and not only for the students of our college, but the students of the other colleges. And in fact, this year there have been international participations also. Dr. Renu Baveja would give you the glimpses of all the activities which we have done. We do extra, interdisciplinary experiments and extra experiments which are not part of the curriculum, and various other activities. And similarly, for enhancing the skill of the lab staff, we organize intra-college lab skill training programs and also do workshops for the school teachers. And Dr. Renu would give you all the details, like the kind of workshops we did for the science teachers of for the government school this year, and which was really, really appreciated. Well, the title of today's workshop on green synthesis of nanoparticles, this is very, very apt and relevant in today's time. And this training workshop, it includes hands-on training as well as lectures, and when I say hands-on training, the event organizers, Dr. Abhijit and Dr. Ruchi, in fact, they went to the lab, they conducted the experiments, and they made video clips also for the benefit of the participants, to show it to the participants. They've really, really worked hard. All the organizers, in fact, they've worked very, very hard. And I'm sure all the participants will find this workshop very interesting, very exciting, and it will greatly, greatly benefit them also. With this, I wish the very best to all the organizers and wish this workshop great success. Thank you.
Thank you, ma'am. Thank you so much. It is your guidance and support that infuses us with the enthusiasm to utilize the prestigious Star College grant in the best possible way. And as you mentioned, ma'am, we are really thankful to Sarkar sir for having joined us. I mean, this is our privilege that he can join us for our humble event. Thank you so much, sir.
Yes, always an honor.
So now I'd like to invite Dr. Renu Baveja, the convener of Star College Scheme, Department of Biochemistry, to say a few words.
Thank you, Dr. Jayata. Good evening, everyone. And I also once again heartily welcome our chief guest of this inaugural function of today's workshop, Dr. Sarkar, and also the speaker of the day, Dr. Anil Kumar Jha. And thank you so much, Professor Shiv Kumar Sadev, who could not join us because he had to go for some meeting in Delhi University, but he conveyed his wishes to us. So I just want to convey thanks to him for his constant support. And of course, thanks to Professor Darshan Manik, who is a constant source of guidance to conduct all these activities. So as a convener of Star College Scheme, I just want to say in this scheme, we conduct many activities, specifically the hands-on training activities for the benefit of the students, as well as the benefit of faculty and our lab staff. So as told by Dr. Darshan Malik, that Shivaji College, our college has received this financial grant under this prestigious Star College Scheme in the year 2019. And since then, we are in a constant mode of conducting a lot of activities under this. And after completion of the 1 year, our college has been awarded grade A for the year 1920. And so these are the, can you please go ahead? So these are the faculty members who are there participating in all these activities, some of them serving as a resource person and some of them as a member of organizing team. Of course, previously we had Professor Neena Vadera and Professor Rashmi Vardhan, as well as our former principal, Dr. Shashi Nijhawan, who were also a part of this team. And still we take a lot of guidance from them when we organize various kinds of the activities. Moving ahead, these are the student-oriented activities which we conducted under the aegis of DBT-sponsored Star College Scheme in the year 1920. So we have conducted, sir, summer training programs, various projects of interdisciplinary nature, of course, industrial visit, because that was a pre-COVID area. So we could be able to go to different industries and prestigious research institutes. Also, we have conducted various additional experiments for better understanding of theory for the students and additional techniques to enhance various, to give exposure to different types of the, kind of techniques which are not the part of their curriculum. We have conducted that also. And we have also conducted various invited lectures. So moving ahead, these are the glimpses of the activities which we have conducted. As you can see on the left panel, we have summer training program. Students visited different laboratories. And also on the right side panel, sir, they have visited Mushroom Cultivation Center, ISER Mohali. And of course, they have also done summer training program in our lab. In the year 2020-21, because we had to shift to the virtual mode. So seminar have been converted to webinar, workshop to online workshop. But at that time also we tried our level best to keep everything hands-on training kind mode. So we have conducted workshop also on bioinformatics and summer training program also on research methodology, and lab tour also converted to a virtual lab tour. So these are the, of course, you can say the change in the glimpses of the activities. Everything now is in the frame as compared to the real picture. But yes, we tried our level best to give training to our students, lab staffs, and our staff members. So these are the glimpses of the workshop which we have conducted. And of course, the online summer training program on research methodology. Then in the year 2021-22, We have again conducted the research methodology with some modification where we asked students to prepare some kind of review. We told them to write down an abstract, to go ahead for the literature survey. Students have submitted the various kinds of assignments. And also we have conducted virtual tour to ISER Mohali, JNU, RCB. And on the right side panel, you can see, as ma'am just mentioned, we have conducted the physical mode training program for the school teachers as well as for the lab staff. And we have also become the knowledge partner under the DST Vigyan Jyoti scheme with the Jawahar Navodaya Vidyalaya, and also conducted various mentoring sessions for the students of class 11 and class 12. So these are the glimpses of the activities which we have conducted in the session 2021-22. And just few months back, can you please move ahead? We have also conducted the workshop on SLR meta-analysis and bibliographic research. That was also online workshop, 5-day workshop, and participate, get to know a lot of information about systemic literature review, and what do they mean by, how do they conduct the meta-analysis, what are the various online tools which are available for the same. Can you move ahead, Dr. Usha? So that's all about various activities. Yes, we have many future plans also, and still many activities are ongoing. So with this, I would like to give a halt, and I expect, and that is why we have planned this workshop, and I'm sure all the participants will get a lot of knowledge about the basics of nanomaterials and their applications, especially the synthesis of nanoparticles, green synthesis. And as ma'am just mentioned, we tried our level best to keep it both basic and little bit more application based, because we have here the participants, not only students, but research scholars and faculty as well. So I'm sure at the end of the third day, you will have an idea about various kinds of nanoparticles and their application. So that's all from my side. And thank you so much for joining again, all the participants, and all the best. Over to you, Dr. Usha.
Thank you, ma'am. It's a privilege for me to introduce our chief guest of the day, Professor Devi P. Sarkar, who is an internationally acclaimed scientist in biochemistry, molecular virology, and gene drug targeting. He has 32-year-long teaching experience for the MSc courses of biochemistry, genetics, biotechnology in University of Delhi and JNU. Sir has held various academic positions in his career. Some of them includes Director, ISER Mohali, Dean, University of Delhi South Campus, Head, Department of Biochemistry, UDSC, Member, Academic and Executive Councils, University of Delhi, Task Force and Project Advisory Committee member for DST, DBT, CSIR, ICMR, etc. Government body member of various reputed colleges of the University of Delhi, Chairperson for the Selection Committee of Scientists, DRDO, Ministry of Defense, also member of Gene Therapy Policy, ICMR, and DBT, Government of India. Sir has also been advisor to UPSC as a jury member. Currently, he's working in the capacity of senior professor in the Department of Biochemistry, UDSC, and acting as joint director, Delhi School of Skill Enhancement and Entrepreneurship Development, IOE, University of Delhi. Sir has been credited with more than 70 publications in national and international journals and 3 books. He has supervised 13 PhD theses, 3 postdoc fellows, scientists, guided more than 40 MSc and PhD students. Professor Sarkar has been conferred with the following awards and distinctions: Shanti Swarup Bhatnagar Prize, CSIR in 1998, Platinum Jubilee Award, Indian Science Congress, recipient of J.C. Bose National Fellowship from DST Sir, elected fellow of INSA, IASC, and Guha Research Conference. Recently, Sir has been awarded Excellence Award for Teachers in Service by the University of Delhi 2021. His valuable teachings can be summarized in the words of Dr. APJ Kalam: if you want to shine like a sun, first burn like a sun. With this brief introduction, I hand over the virtual mic to you, sir.
Sarkar, sir.
Yes. Jaita,
Yes, sir.
Yes, sir, you're
Yeah,
audible.
yeah.
Yes, sir,
So thank you so much, Usha, Jaita, Professor Malik, and all colleagues of our biochemistry department and the entire Shivaji College fraternity, and of course our honorable principal sir, who is all the time standing with the all kinds of college activities and highly inspiring all the time. It's a very dynamic environment of this college, and I have been I'm lucky and fortunate that for a long time, since I'm a teacher in this department of biochemistry, South Campus. I'm fortunate to visit and interact with many colleges, but particularly the Shivaji College, I had many occasions to be with all the departments, not only with the biochemistry, but with all the departments. So I congratulate all of you in this particular endeavor of a 3 days online webinar on the several aspects of green synthesis of nanoparticles and its biomedical applications. It is absolutely the choice of the day and the demand of the day that you have so rightly chosen, and with some of our eminent experts who will be having sharing their experience, hand-on experience, and some of our our own college teachers like Dr. Misra, I think Dr. Avijit Misra, and
yes,
we have also our very first and foremost speaker from a very eminent Central University in Bhagalpur, and that I'm very happy to witness and see all the stars signing and trying to sign and illuminate other would-be stars and already stars, and maybe like more than 1,000 sun in this galaxy. So with my all this thing that what the way they have described me as a teacher who is trying to serve this university and as well as all the allied or national institutions. I'm very fortunate and feel elated today that some of our bright students, like whom I had the opportunity to interact during our MSc biochemistry courses, like Usha, Renu, and many of them, like particularly in the biochemistry. And of course, there are like they are my I have indirectly interacted with like for this instance, the organizer, one of the organizers, like who happened to be PhD from National Institute of Immunology, but I had the opportunity to have her with the interaction with her while she was working in that National Institute of Immunology. And one of the very real doyen in biotechnology, Professor Sudhanshu Brati, if I'm right. Okay, Jaita. So that was the real my collections, my real album, and I rejoice. I'll keep on rejoicing for my whole life that yes, what you said, that we have to help each other like hand holding, and in our turn, you will, and your turn, you will also do the same thing. Maybe whatever I could not do so far, and I'm aspiring to do, I think you will do much better than what I have been not able to do. So with all this thing, I congratulate once again the college, entire college faculty, the students, dear students, and the dear participants who are with us to get the benefit of nanoparticles and green. We all know about synthesis, which are earlier it was not green, but now it is green because the way they are synthesized, I have some idea while I was interacting with National Chemical Laboratory, some of the very young that time scientists who were really started it. So I only knew that some of the gold nanoparticles they were synthesized that time taking the help of plant physiology, like plant biosynthetic pathway. So maybe in this deliberation, our experts will also shed light on why it is green, why not red, why not why not only nanoparticles. So that is some special character which I am expecting they will illuminate and they will enlighten us with their best of their capacities. And I wish you again very good luck and thank you so much for this honor and the privilege the way I have been enjoying so far. All the best. God bless you.
Thank you.
Thank you so much.
Thank you, sir.
so
Thank you,
much,
sir. Thank you.
So
Thank you,
I
sir.
feel it is our
Thank you very much,
privilege that we were taught by you. Thank you so much, sir, for
Yes,
your
sir.
best wishes and taking out time from your busy schedule. Your words of encouragement always drive us to strive for perfect. Thanks a lot, sir.
Thank you, sir.
Before we take the program ahead, I request everyone to switch on their camera for virtual group photo. I request all the participants to please switch on their camera.
And everyone give a big cheese smile.
Just one last click. I think we're done.
You announce an award for the smiling competition.
Yes, sir.
Sure, sir.
Okay. Thank you so much.
Thank you so much, sir. Thank you.
Okay.
Thank you. Thanks.
Thank you, sir. My regards.
As we reach towards the end of the inaugural session, I now invite Dr. Abhijit Mishra to take the session forward and introduce our keynote speaker of the day, Dr. Anil Kancha. Over to you, Dr. Abhijit.
Thank you so much, ma'am. Good evening, all of you. It's a great pleasure for me to introduce our speaker, Dr. Anil Kancha from Department of Chemistry, Tilkamanjhi University, Bhagalpur. Today, we are here to listen and learn about bio-nanotechnology, the promising cues of nanomaterial synthesis using bio-nanotechnology, a truly sustainable approach. This is a subject in which we should all be deeply interested because bio-nanotechnology has emerged as an upcoming field and is significantly interdisciplinary in nature since it combines physical laws, chemical properties, and biological principles on the nanoscale. Our speaker, although having spent almost his entire career in research and academics, he did his MPhil and PhD from University of Cambridge, England. Recently, he served as visiting professor under DST Royal Society, GCRF Newton Bhabha project at School of Chemical and Process Engineering, University of Leeds, UK. He published more than 75 research papers, 1 edited book, and 12 book chapters, and filed 1 patent in the bio-nanotechnology area. He has supervised 5 PhD students and more than 20 MTech students for dissertation. Dr. Jha, it gives us great pleasure to have you with us, sir, as we have been eagerly waiting to hear your personal account on this topic. I am pleased to welcome Dr. Anil Kancha. Sir, over to you.
It's my privilege. Thank you, Abhijit, for introducing me so nicely, and the college members, all of you. My gratitude to you all for calling me to share my experiences with bio-nanotechnology. Whatever I've learned, I would like to humbly share all those experiences with you. So my gratitude to you all and for your kind words, Abhijit and the members of the committee. Now I switch over to the slide straight away. And just to save time, share screen. Yes. Share screen and now. So is it visible to you all?
Yes, sir.
Okay. So let us begin. the promising cues of nanomaterial synthesis using bio-nanotechnology, a truly sustainable approach. We have already known about it, discussed about it. So next will be the outline of my presentation. And I think it is coming, right? Or should I, is it okay? It's coming?
Yes, sir. Yes, sir. You could
Yes,
make it
sir.
full screen if you want.
Okay, full screen, how to do this?
So on the bottom, there's that
There is
bottom
an
right,
option, right?
behind the beside
I
the
think
book. Yes.
is it full screen now? No?
No, sir.
Oof,
So on the
we go.
bottom panel, the one beside the book.
Is it there?
Yes.
Yes, sir. Yes, yes.
So let us be a bit quick because number of slides out of excitement has increased so much. So okay, so understanding nature, basically, just for knowing about bio-nanotechnology, let us understand nature. We need bit of scientific instinct for that, philosophical approach with a touch of mythology. So we have heard many times people chanting this mantra: Purnamidam, Purnamadam, Purnat, Purnamudachyate, Purnashya, Purnamadaya, Purnamevavashishyate. That means our universe is Brahma, the Almighty God, and that is complete in itself in all respects. And its components are interacting with each other to manifest different phenomena. This is probably true and applicable from the collapse of stars to the assembly of materials, including nanomaterials. So, what is the problem? Siddhant? I'm very sorry, my apologies. So the ultimate fact to realize is the nature is ruled by the principles of thermodynamics and supramolecular chemistry that we perceive basically is nanochemistry, right from the growth of a leaf or for a flower bud to bone, regeneration of leaf to skin, and the repair of capillaries and dissolution of blood clots is obeyed by the above mentioned principles. It is for us to realize, because once somebody undergoes a stroke, doctor says, okay, after 36 hours, I will not say. Till 36 hours, I'll not say anything. Why the bone repair is always left for 6 weeks? This is nothing. Basically, the underlying supramolecular chemistry principles and the thermodynamic principles come into play, and then if the matter is healed. Well, I go further to just elaborate my fact that this very fact that nature is indeed amazing. It has unique conglomerate of unicellular prokaryotes, eukaryotes among plants and animal kingdoms. It has unicellular alga and giant pines and tree ferns. It has simple amoeba, plasmodium, hydra to complex mammalian bodies. Mother Nature is indeed full of amusements. Among all these, one thing is common: their basic constitution and adaptability. That has been the raw material for the exponential phenomenon of evolution. Well, these metabolite content have kept them in the train of evolution, because they need to share the stresses from time to time, and that's what we call adaptability. And see, net metabolite content of the different organisms and their individual fluxes, metabolic fluxes, make them unique along the vast canvas of Mother Nature. Life as such, is an interesting story of inorganic structures and organic materials, or the vice versa. The crux, basically, what is the basic thing on which we can address the problems? So natural cohorts commenced their, reduce it to that. Let me complete. Yes. Natural cohorts commenced their organizational endeavor taking use of inorganic materials for various purposes. And this indeed led to the development of a myriad of organic structures and subsequently the living systems. The most beautiful part is the ionic balance at cellular level is still maintained. And this justifies the existence of rather importance of chemistry in our day-to-day life. That is, I mean, the pH balance or the divalent, monovalent cation balance, all these things are basically that very much archaic discipline which was bestowed upon a cell, upon our body. So let us have a brief timeline, have a look at the brief timeline of nanotechnology. This gentleman, we all know, Richard Feynman, he gave the talk that there is plenty of room at the bottom and just gave the idea of nanotechnology. But he termed, Norio Taniguchi, gave the term nanotechnology in 1974. And things started consolidating with time. This gentleman, Eric Drexler, prompted the nanoscale phenomenon through the book Engines of Creation, The Coming Era of Nanotechnology, Nanosystems, Molecular Machinery, Manufacturing, and Computations. So this is what is the story in brief about these three, about the nanotechnology. And excuse me, I'm getting back just to make you understand. Yes, these three people should be acknowledged as champions. Eric Drexler gave the molecular machine concept, which is a theoretical aspect, and now getting transcribed into reality slowly, though. Now, so we should acknowledge these three people as champions of nanotechnology: Feynman, Taniguchi, and Drexler. So let us take a look in our country, at our country, how it came up, how it was grown. Professor C.N.R. Rao should be credited for this. And actually, he paved the path for nanoscience and technology in our country later on during late 90s, 98, 97, 99, basically. The work on bio-nanotechnology commenced in a sporadic manner at IIT Madras by Professor Thallapil Pradeep, who used lactobacilli for intracellular synthesis of silver nanoparticles. Professor Murli Sastry and his group at NCL Pune during 2001 onwards, they used fungi and other plant systems. What we contributed was our efforts. We commenced our efforts in 2002 and could publish only after 5 years of our effort in 2007. We have pioneered the use of pteridophytes, gymnosperms, kitchen wastes, pharmaceutical wastes, lower animals, and animal processing wastes for synthesizing different nanomaterials. So let us have a brief look what is nanoscience and technology. So nanoscience and technology is the manipulation of matter at the nanometer scale to create novel structures, devices, and or the systems. If we are dealing with the structures, we are dealing with the materials. It may be metal, it may be oxide, it may be chalcognite or the quantum dots, carbon dots, etc., etc. Then devices, these are the structures, these are the things which we design, through which we design the senses. We deal with the structures, we come to devices, and then we come to the systems, nano electromechanical systems. So these are the three stages we can grow from structures to devices, and then we reach the systems. So to make it further simple, 1 millimeter equals to 1,000 micrometers. 1 micrometer equals to 1,000 nanometers. So 1 nanometers equals 10 raised to the power minus 9. That is 1 billionth of a meter. The term nanoparticle is a mixture of the word nanos, that is a Greek word, the dwarf, and the particulum, Latin, that is particle. So this is what is in brief about nanotechnology. Well, the size here matters a lot. It is not just how big you are. It is an elephant and a rat. it's what you can do with it. So increase, this is a solid structure, then break in smaller pieces, further smaller pieces, and then you see the surface area has increased. So this is the beauty of nanomaterial. So photonic properties, all chemical, physical properties, they change once the particle size goes down. So this is multidisciplinary science. This earlier we had an era, the science of electrons. Then we moved to the science of atoms and molecule. Now we are into the science of nanoparticles, nanoscience and technology. And you can see all these areas are affected. I could not accommodate more. So you can see the jubilation in this mouse. And he has learned that how the things are being run by the nanoscience and technology. So how can we synthesize nanomaterials? We have two options, top down and then the bottom up. Top down, take the large structure and make the small structure. Then we take the small structure and then take the bottom up procedure, make a nanomaterial. So this is how so do different, just to further simplify, you take a large piece of stone and keep on cutting and make a small particle. Similarly, the baby playing with toy, smaller structures making larger structures, smaller structures, atom, molecules, and then atom by atom, molecule by molecule, cluster by cluster, and you get the desired material. So principle, what is the basic principle involved? These are the outlines, but we must know what is the basic principle underlying the top-down approach is to take a bulk material and then modify it into the desired nanostructure. The method is considered to be of choice when complex nanomaterials are to be fabricated. The bottom-up or self-assembly refers to the construction of a structure atom by atom, molecule by molecule, or cluster by cluster, obeying the principles of supramolecular chemistry and thermodynamics. So mechanism as such, just we'll have to perceive why and how. Because I was taught at Cambridge that science without reason is just journalism. So we must reason, and what we do basically. So what we do, we take an ionic solution, then it dissociates, it ionizes, metal salts, it ionizes, it dissociates, then it follows first order, second order kinetics. Then comes the availability of free energy, thermodynamics. That is the pivotal point. We need to generate the free energy for phase transformation. That will allow it to jump the phase from the micro scale to the nanoscale. So where are we in bio-nanotechnology? Nanotechnology, as we saw, has been defined as engineering and manufacturing at nanomaterial scales with atomic precision. Biotechnology harnesses biological processes and uses them for our own applications. So bio-nanotechnology is a subset of nanotechnology, atom level engineering and manufacturing using biological precedents for the guidance. So this is the trigger, this is the inspiration. So bioscience helping in development of nanoparticles is bio-nanoscience and technology. So it is coming, sorry. So what we take into use, we take use of nature, take use of benign microbes, use of plant specimens, use of plant organs, leaves, fruits, even roots, all these things we will see in subsequent slides. And then other members of the plant kingdom, gymnosperms, pteridophytes, and bryophytes, and other members. Then expiry and pharmaceutical wastes, expiry medicines, pharmaceutical wastes, kitchen wastes, organic wastes, biological wastes. Well, all these things ensure that we are not causing any toxicity to the environment. So they are truly green because the source is green. The solvent we are taking is there. Most of them are green. We do not use any toxic solvent. I mean, like ether or chloroform or benzene. We just hire 50% to 30% to 70% ethanol for extraction. We will come to know that. We will discuss it in subsequent slides. So question is, why microbes? Why should we hire microbes? Microorganisms are natural producers of nanoscale materials. Being the cell factories themselves, they have proved themselves to be promising tools for emerging technologies and biomedical applications. They are bestowed with molecular weaponry to circumvent the various types of environmental shears. And these metabolites prove to be helpful in our pursuit of nanomaterial synthesis. These are the microbes which were used earlier, but we have hired only this one. Many people have used this: Armonospora, Pseudomonas, Studorgibe, Bacillus subtilis, Escherichia coli, Magnetosporidium, etc. And among prokaryotes and among eukaryotes, Fusarium oxysporum, Verticillium, Penicillium, Coletotrichum, Vulvaria, Saccharomyces cerevisiae, Saccharomyces pombe, Candida glabrata, MKY, etc. So we have taken Saccharomyces cerevisiae from this lot. We will for our use for synthesizing the nanomaterials. So here, let us ponder over the real issues. Why? If bacteria can synthesize metal nanoparticles, can plant organisms such as fungi do so? Let us try. And we tried, we got the result. Can we do it extracellular manner? This point is very valid over here, because earlier we got the inspiration from Thallapil Pradeep's paper in 2001 or 2. That was it was in Agwante Kimai or somewhere very prestigious journal, Langmuir, I'm sorry. So we found it, that was inside the cell. What can we do about it? So we modulated the protocol. We will discuss it later on. And we got it in extracellular manner. And size was much reduced. So we need to modulate the system. We need to lower the organism. We need to make the microorganism more robust to take a shear, and then give it extracellularly. We did that and we were successful. What is the biochemical process leading to nanoparticle formation? That is the real issue. We must know what is happening around. We are not doing journalism, we are doing science. We must reason why it is happening. Can we extend the methodology to other chemicals, soft chemicals? Can citric acid do that? Can tartaric acid do that? Stearic acid do that? Yes, they do. But it will be completely out of context over here. But these are the things we must ponder. And we have been successful in doing, taking use of these soft chemicals, these organic acids, and they have given us very, very encouraging result as a green chemical. Can we try different compositions? Sulfides, can we make quantum dots? Can we make oxides, even higher oxides? What we never tried was carbon nanotubes or anything like that. We always concentrated on inorganic nanoparticles using the biological systems. Anyway, is size control possible? Is better monodispersity possible? You can understand the grain of sand. We can perceive the monodispersity means particle to particle separation, just like different grains of sand and a heap of mud, agglomerate. So this is the difference. So we must have better monodispersity. How about nanoparticle shape modulation? Of course, it is possible. You do, people are achieving. And can we use extract of plants, fruits as for biosynthesis in biosynthesis? Yes, the answer is yes. Can animal system also participate in bionanосynthesis? Why animal system? Yes. Animal systems contribute very much significantly towards the nanosynthesis because they have miracle molecules inside them. Dead mosquitoes, dead flies, and others. We will know in subsequent slides about it. And one more thing we must ponder over here, that we have new version every day adding of COVID. Why pleomorphic virus is getting changed all the time? Because we are wasting protein outside. We are leaving it outside. Fish processing discard. I mean, goat processing discard, and chicken processing discard. All these are lying. I mean, not all of them are consumed. They just fester in the open, and they give a new attire, new veil, new dress to the virus, new coat to the virus. That's why virus is emerging more resistant and new variants are coming naturally. So we thought about it, and we tried to use the animal system, animal tissues to create a few more significant nanomaterials for sanitation and other purposes. We will discuss it later on. Can we do anything about domestic wastes, kitchen wastes, or expired medicines? They are either burnt or drained. In both the cases, they are causing pollution. If they go to water, they pollute the water and breed the resistant strains of bacteria. And if they are burnt, they are just creating a menace in air. So can we do anything about domestic wastes, fruit peels, vegetable peels, etc.? We will learn about these things in subsequent slides. So just for an example, here we have taken use of yeast and lactobacillus for synthesizing quantum.cds nanoparticles. Here you can see it is more intense, it is less intense, and the particle size was very, very less here. Very less particle size. It was 5 to 10 nanometers and 13. I mean, you can see the peak broadening. That is the sign that the material has got transformed into nanomaterial. XRD is the mirror of synthesis. If the XRD signals are getting broadened at the baseline, that indicates that it is nanomaterial, nano transformation has taken place. So bandwidth has also appreciably enhanced here. So we got it published in 2010. Here again, you can see lead sulfide nanoparticles using yeast. Yeast has quinones at the membrane level detoxification system, and they help in tautomerization and then create energy. And there are other things which we will discuss later on. I mean, if they have, this is membrane bound quinone, then they have cytoplasmic metabolite weaponry, phytogelatin, HMT1, glutathione, other monoxygenases, etc. The result was we got it in the domain of sub-millimeters, sub nanometers, 0.667. 6.67 angstroms, and that was the highest was 6.95 nanometer lead sulfide nanoparticles. It was quite encouraging to us. Then another example is here, titanium dioxide nanoparticles using yeast and lactobacilli. Here, barium titanate nanoparticles using yeast and lactobacilli. Barium titanate is very, very significant. It is material because it is used in making the pacemakers. So now let us reason with lactobacilli. Why lactobacilli should deliver nano? Lactobacilli, like most of the bacteria, have a negative electrokinetic potential, which readily attracts the cations, and this step probably acts as the crux of procedure for biosynthesis. Addition of reducing agents like glucose tends to lower the value of oxidation reduction potential, which we generally add, we manipulate, we play the game with glucose. So I'll open up a little bit later on. So what happened? क्या हुआ इसमें? Slide को क्या हुआ?
So screen sharing has stopped. So please share your screen again.
Now, is it there?
No, sir. See the screen.
Okay. Just a moment, ma'am. Sorry. Share screen. Okay. No.
Yes, sir. Now it is visible.
Sorry. Really sorry. So let me get back to. So here I'm picking up lactobacilli. Like most of the bacteria have a negative electrokinetic potential. This fact was deciphered in 40s. It's nothing new I'm suggesting. So addition of reducing sugars like glucose tends to lower the value of oxidation reduction potential, and this oxidation reduction potential is designated as RH2, the negative logarithm of partial part pressure of gaseous hydrogen. So lactic acid bacteria are gram-negative, functionally related by their ability to produce lactic acid through homo or heterofermentive carbohydrate metabolism. So the principal metabolic product of the bacteria, lactic acid, is a weak organic acid and one of the smallest molecules with an asymmetrical carbon in location of alpha and carboxylic function. So it has this feature allows the existence of two different stereoisomeric forms, L and D. In addition to this optical activity, the lactic acid molecule has simultaneous carboxylic and hydroxyl group, allowing it to react either as an acid or as an alcohol. So what is the advantage? Advantage is that this dual functionality initiates the spontaneous formation on intramolecular esters, oligomers, with discharge of water leading to a thermodynamic equilibrium subject to the solution concentration and age. We took advantage of this very statement. We just incubated bacteria for 72 hours in presence of different concentrations of a carbohydrate, that is glucose, and we got different results. So why did it happen? Because thermodynamically, heat of dissociation amounts to 63 calorie per mole at room temperature, and the value of free energy of dissociation amounts to 5,000 calorie per mole for lactic acid. If it dissociates, it gives you energy. And this dissociation basically is the source of free energy for nanotransformation to take place. This probably ensures availability of energy in the culture solution along with other crux metabolite fluxes, leading to a successful nanotransformation. Now we come to, I think it is visible to you all. I could not change the color, my apologies. And my problem is, I mean, we are dealing with here we are dealing with fungi. This is yeast, this is aspergillus, this is fusarium. Why a fungus should give? On the membrane wall we have quinones, and quinones are capable of undergoing tautomerization, ketoform to enol form, and inside we have phytogelatin, HMT, cytochrome P450 and other things. And these things are basically inducing the formation of nanomaterials among fungi. Quinones and this phytogelatin, they have metallothionein also interest, but in plant system, phytogelatin is the major player. So here it is responding and giving us the nanoparticle. Now we come to the plant system. We all know about Bhringaraj. It's very common, Eclipta alba. That gave us silver nanoparticle. The particle size was appreciably small. It was less than 20 nanometers. Then Sir was discussing about Bilbapatra, Agel marmelas leaf. So it has three leaves. In Ayurveda, it says that Tridosh Nashak, it is called. So Tridosh mean Rajasat and Tamagun. These three keep on getting enhanced and getting lowered from time to time in every person. And Ma Parvati took this to just survive herself during forgetting Lord Shiva. There is a lot of other story related to Bilbapatra. We will discuss this some other time. But the point is, we took the alcoholic extract and incubated it for 10 minutes, and we got this gold nanoparticle. The particle size was, average particle size was 20 nanometers, or even most of them were below that. So it was quite encouraging, and our travel continued. So we just wanted to assess ourselves to know whether the plant system of different kinds, xerophytes, mesophytes, and hydrophytes, will they give or will not they give? They gave. They gave due to their own individual physiology. They gave silver nanoparticles. Xerophyte gave because it had organic acid. It has saproquinone. It has some other protocatachoic acid and other things. I mean, other compounds inside it. We did the bit of chemistry and then we got it. The result was excellent. Similarly, my student did it, I mean, taking use of this garlic cloves. She synthesized gold, silver, and platinum, and we tried it, I mean, against the breast cancer cell lines and lung cancer cell lines. Initial results were very encouraging, but that needs to be optimized. Similarly, Punica granata Merrill also gave us gold, silver, and platinum. So paper betel, simple paper betel, that gave us gold, silver, and platinum. All these things here. So rose petals, we took I mean, hired rose petals for this purpose. And first of all, we did the chemistry, we reasoned with it, and we got gold nanoparticles taking use of rose petals. Then orange juice. By taking use of orange juice, we were able to synthesize the metal as well as the oxide, zinc oxide, as well as silver nanoparticles. I mean, that was quite encouraging. It has this very promising thing that is hesperidine. It is good treatment against venous ulcers. And if you add silver to it, it is very, very convincing treatment. For diabetic foot and venous ulcers, need to be optimized, of course, need to be clinically tested. But preliminary results were very encouraging under supervision of a doctor. So what could be the candidate metabolites, you know, whatever we saw? Organic and amino acids, they participate. Polypeptides and proteins, terpenoids, alkaloids, steroids, flavonoids, non-flavonoids like tannins, stilbenes, thiocyanates, etc. These things participate, help in the synthesis of nanomaterials. All we need to know is to learn about their metabolic bustle, how they are synthesized, what is their individual characteristic in response to a given temperature and pH. If we modulate the conditions, how do they behave, what is their fate, and can we take use of those fates in the synthesis of nanomaterials of our choice. Our other potential plant resources which have not been tapped yet: lichens not explored, unexplored completely, mycorrhiza unexplored. They could be excellent biofertilizers if we take use of them. Bryophytes broadly unexplored. Very few papers are available. Members of pteridophytes marginally explored by us. And then gymnosperms. They are also marginally explored by us. So these are the natural resources. We can take them into use for synthesizing different nanomaterials. They are not causing any pollution, and so we can hire them for our purposes. So here, terrace species very common, Marsilia adiantum. This was done by my student Sabiha a few years ago. And then one of my students tried her hand on the potato peels to synthesize silver nanoparticles. And I asked her to reason. She found hydrocinamic acid, chlorogenic acid, caffeic acid, hydroxybenzoic acid, gallic acid, protocatachoic acid. These are very labile metabolites, you know, in response to pH and temperature. And they have a definite metabolism in which they release energy, and that energy transforms the micro scale material to the nano scale material. It's very, very small sized. Similarly, orange peels were hard for this purpose, and we got the result. So these are the confirmation procedures in visible, analysis. Then this is how the reaction matures with time. Then we confirm it with XRD with the help of a physicist. That is not my domain. And then a SEM image is taken just to confirm. Then at this very point, can we think that can animals contribute? Like banana fly, the green fly, which comes over, mango, cockroaches, mosquitoes, ants, slaughterhouse wastes, fish dressings, chicken dressings. Well, they do. I told you that if you don't, take them into proper use, well, one good use could be induced fossilization. That is my concept. You induce fossilization and transform them back to the hydrocarbon stage. That will be nothing like that. A bit of that is being done, pursued in Sweden from 2008 or 7. But we are not doing anything. So we thought that, okay, fine, let us do something about it. The waste should be made, worth by just synthesizing nanomaterials through them. So we started with Periplaneta americana. We removed the wing, we take the chitinous body wall, we took the chitinous body wall, then we added to it, and we got one gold nanoparticles, zinc oxide nanoparticles, and quantum dot CDS nanoparticles. Why does it happen? It has troponin, tropomyosin, it has a chitinous body wall, acetyl glucosamine. So it is beautifully modulated under conditions of pH and temperature. And it gives us the material which we of our choice. As you can see, this is zinc oxide, this is gold nanoparticle, and this is quantum dot, that is CDS, cadmium sulfide nanoparticle. This work was, nominated for a Nobel Prize. IG Nobel Prize. I must correct myself. So we stood third on that. We didn't get that, but nevertheless, effort was there. We took that. So this triggered an idea. Cockroaches are nuisance in the household, but we don't kill cockroaches. Dead cockroaches we took, and they were not sedated by using Dagon or any other chemical. Dead cockroaches. And then we got the guts removed, and then we took the integuments for this particular purpose. And we got very, very, very important, very interesting results. They have, most of them, just similarly, we took banana fly. Similar is the story. We have metallothionein genes are triggered. Then we have acetyl glucosamine getting changed all the time, transformed in response to the pH and temperature, and we are getting the desired result. Can you imagine to get quantum dot from dead banana fly? Only bio-nanotechnology can make it possible. The story continues with Culex mosquito. 10 Culex mosquito dead, sacrificed, and boiled, and we got silver nanoparticles, quantum dots, and other things. We had also synthesized silver, but we have reported only quantum dots. Fish processing discard, you can see only the guts of the fish. And then similar is the story. Tropomyosin is playing the game, then metallothionein is playing the game, and we are getting what we aim to get. So these are the results. And then we see very common wastage in the market. You can see the gut of this goat being sacrificed and thrown as such. These are the new dresses for viruses. If we don't address it properly, we are going to get more strands of such coronaviruses or any other viruses. I tell you, all we need to do is to make such a material out of them that we don't need to apply to over our faces, don't need to eat them, but at least we can use them for sanitation purposes, sanitize the drains, sanitize the, I mean, public facilities and all those places. So zinc oxide we have made, and the effect is very, very good. As I mean, because zinc oxide takes away the odor, because it dehumidifies the environment, and odor is always associated with humidity most of the times. So this is very effective, and the chemistry is always the common, same tropomyosin, same metallothionein. All these things are working, and we are getting the results. Chicken intestine broth, again, we prepare the broth, we regulate the parameters, and we get the nanoparticles. One more interesting thing is that, as I told you, just it is a representative slide. We have, my student has worked on other pharmaceuticals also, those are expired. So norfloxacin is deuterionic, and we took use of norfloxacin for synthesizing nanomaterials, and we reasoned with it. In literature we found that it is deuterionic, and it is so anionic form, cationic form, both are exchanging over the energy. So every case you are getting the energy all the time. You take the metal and metal ion, you get metal nanoparticles. If you take metal ion, and if you have requisite number of electrons or the requisite conditions for oxidizing, for oxidation or towards the lower side of the pH, we get chalcogonide nanoparticles, that is the quantum dot nanoparticles. So the similar thing, we get better results with combiflam, we get results with betnosol and others. Paracetamol even also does that. So the norfloxacin is a representative molecule for us, which basically signifies that the expired medicines can also be taken into use for preparing nanomaterials for remediation purposes, for cleaning purposes, for sanitation purposes. So we had tried to make, this is paper cutting, to make skin treatment lotion out of that. But that got stuck in regulations and all that. So we use the same for sanitation of drains, for sanitation of laboratories, sanitation of the public places, I mean WCs and all that. So that is the encouragement. And one more thing we have prepared out of it is food freshener, medicated food freshener. So I come to very, very basic about, what can be done, not only materials, can we do something about whatever we are making? So we have multi-purpose wound healer dressing lotion that is bio-nano based, and it is effective against cuts, wounds, viral attacks, that is herpes, psoriasis, nail keratosis, second degree burns, and osteomyelitis. May also act as an antiseptic germicidal if suitably diluted, can function as aftershave lotion. We have got it tested against toxicity, but still a few tests are to be done with it. Then only we can launch and file a patent. So let us just try to trigger more ideas into our minds by taking use of the above lotion. Tentatively, we call it Curion Plus. We aim to work and developing in order to develop nanomaterial based black bodies to eliminate the diseases like dengue, malaria, encephalitis, chikungunya, osteomyelitis, tuberculosis of bone, and a few types of cancer. This concept we are thinking about may be called bio-orthogonal nanotechnology, because the system is doing its own job, your material is doing its own job, it is not interfering, it is in orthogonality, working with the system. Black bodies will be the answer to the robots. Robots are theoretical, and robots have many things to face before they come to the floor. There are many issues. We can discuss it later on. major thing is that their control and their navigation, and there are so many types of nanorobots. They might sort of get, completely collide to each other and might create further complications inside the body. So it is a theoretical concept. So I am advocating about nano black bodies. We take the suitable carbon dots and take our lotion and other things and manipulate the bio-nano composite, material what we have prepared. Then we can answer. We have got in osteomyelitis, we have got results. We have got result in malaria, dengue, and other things. So we are feeling quite encouraged. Tomorrow, Dr. Abhijit might further elaborate on the medical side, biomedical applications. That is not my domain. So our products, ready technologies, just in brief, fabrication, we have fabricated nanomaterial-based multi-purpose face mask. We have an indelible link. We have a patent on that. Filed a patent on that, we have not been granted. And 17 green nanomaterial synthesis protocols, nanomaterial-based multi-purpose skin care lotion, effective against that what I have discussed, burn injuries, deep cuts, bed sore, nail keratosis, fungal dermatitis, and psoriasis. Nanomaterial-based sanitizer, deodorizer for general sanitation of toilets and domestic waste, taking use of pharmaceutical waste as well as kitchen waste. Nanomaterial-based medical food freshening spray, medicated completely. It is topical, it is safe. And then bio-nanomaterial-based anti-termites. So these are the ready products we have developed taking use of bio-nanotechnology. Current status is, I have worked recently for GCRF, Royal Society GCRF fund to develop photovoltaic quantum dot glass to purify wastewater, drain water to drinking water, working on material for radiation protection and rust-proof paints inspired by Iron Pillar of Delhi. That material is very encouraging. And bio-nanomaterial embedded bulletproof jackets to stop bleeding among the personals. It will be quite effective if it is successful. Phase 2 is very, very encouraging result. It has given, now it is in phase 3. We will discuss it later. So materials for foldable roads, can we imagine that? We need not dig the road. We can have materials and fold it. If you want to, just you open the road and then you do the job and then put it on the place. And then eternal thermochromic paints for our buildings. Once you paint and forget it, that will save the energy. At least during winter, it gets darker, and during summer, it gets lighter. Lightweight for jet turbine materials in order to curtail the fuel consumption. Silicon for biomedical energy. Uses for domestic waste. So this is what we have been working upon at the moment. So let us talk about the sustainability. There is a lot of hue and cry. Once one new technology comes to the floor, these people start doing these things, sustainability. The sustainability and circular economy bears on our ability to design our waste and pollution, keep products and materials in use for as long as possible and regenerate natural systems. Well, bio-nanotechnology does that. It is doing that. We are dealing with nature. In other words, the circular economy is restorative, whereas nothing or little is thrown away, rather it is reused or regenerated, thus eliminating or reducing waste as well as the use of resources. If the world economy embraces circular economy strategies and increases circularity from current 8.6 to 17%, which will result in the reduction of global emissions by 39% and material footprint by 28%. At this very point, bio-nanotechnology ensures the reuse of every component of Mother Nature. our field, bio-nanotechnology, stands tall and confident. In bio-nanotechnological procedure, nothing is considered waste. That is the beauty of this procedure. We have proved it through our research experience by utilizing varieties of plants, microbes, animals, or kitchen pharmaceutical wastes. It is a brilliant compliance to the principles of circular economy and sustainability. So in nutshell, these are the procedures I have shown here. You take soft chemical, you take pharmaceutical waste. We consider organic acid and expired pharmaceuticals both as soft chemical. And these are the things, these are the phenomenon, these are the procedures accomplished that ensure the delivery of nanomaterials. Generation of free energy is at the center. Then you take higher flower plants, food beneficiaries, take butter, take honey, other things, and you get nanomaterial. And these are the reasons why it is happening. Lower animals, higher animal processing discards. These are the processes. This is the generation of free energy. These are the sources. So I've tried to do it in one thing rather. I have not done it. My friend Professor Kamal has prepared it. Let us be honest about it. So just to sum up what we have done. So in conclusion, it is the metabolic status, the net metabolic weaponry of an organism which matters in bio-nanotechnology. If you want to hire any organism, we must know the chemistry, the metabolic weaponry, the metabolic flux. That is very important. Reactive response in terms of signal transduction at molecular level seemingly is operative in case of microbes, which could vary according to the organism type. Prokaryotes will have larger molecules, eukaryotes will have much smaller molecules, better monodispersity. Among plant specimens, parts, organs, the individual chemistry matters a lot. That is metabolic treasure, metabolic flux. While using the organic wastes or expired medicine, a slightly different cue will be applicable, but would be more amenable. Yeah, of course. We will have to design our own experimental cues. Whatever suits. My student Mugdha, she did it with alcohol. I asked her to kindly try water extract. We got very good result. We prepared a lotion. In our household, in first degree burns, even in second degree burns, we apply potato peel. It is very soothing. Solanine is the candidate alkaloid, and there are many others. Protocatechic acid is there, comaric acid is there. It helps. So that is how it works. Bio-nanotechnology. That is the beauty of the protocol. Rest is dependent upon the modulating parameter. We must not forget pH and temperature. They are the fuels of thermodynamics. Thermodynamics plays in the hands of pH and temperature. So if we give all these things, nature never fails to deliver. Nature never fails to deliver. This is all about bio-nanotechnology. These are our collaborators, Professor Kamal Prasad, currently serving University Department of Physics, Professor R. Kulkarni. He helped us during the earlier period of our work, did a lot of characterization for us. His collaborator is in our so many papers, at least 30 papers we have shared together. And he's Professor Eja from University of Leeds, UK, where I had been for a while. Rather 6 months, twice. And this is Dr. Bharat Kale, Director CMAT. It's me, of course, you can recognize me. This is Bhupesh Mishra from IIT. Illinois Institute of Technology and University of Leeds. He's in joint appointment. He was my host scientist. He's Professor Eja. This Javed and Simon Lloyd, my lab support. G46 was my lab in which I used to work. Another photographs. And then John Paizetek. John, I always, the tongue twisting name, I always get stuck. So John Paitek, he's from Basel, Switzerland. He visited our lab a few years ago. This is our research group members, students. These are all my students. These two are, he's Professor Prasad, is Dr. Rakesh Singh, my colleagues, and these are our PhD students. These four were my students. He belonged to Kamal, and this guy belonged to Rakesh. So at last, my Gurudev, Professor Peter Morris, CBFRS, University of Nottingham in 2019, 18, and visited him. So in nutshell, the town is emerging from bio-nanotechnology, little bio-nanotechnology. Let us be happy. Let us be completely triggered, motivated, and ready to deliver. So thank you very much for your kind attention and your patient hearing. Thank you.
Thank you very much, Dr. Anal Jha, for this enlightening presentation on the synthesis of nanomaterials using nanotechnology. Your talk was particularly appropriate at this time when people are considering new initiatives for sustainable development. Moreover, you have well taught us the need of utilizing domestic waste, microbes, expired medicines, etc. for the production of nanomaterials. Now, we can move forward and begin the questionnaire session for today's workshop. Participants can post their queries and questions in the chat box. So, sir, can I start reading the questions? The first question is, what is the cost difference for the production of nanomaterials from traditional methods and from bio-nanotechnology?
Yeah, right. It is just a difference of high cost to no cost. Yeah, because you are just say, for example, you are hiring a chemical method and or a physical method. It has a lot of capital intensity as well as environmental threat. So here we can manage an experiment within a few thousands, whereas in case of a physical method, it may cost us in lakhs, or in case of chemical method, it could be in thousands. So it is very, very amenable, very much eco-friendly and very much low cost. So you got the answer? It's a pleasure. Any further questions?
Yes, sir. So we have some more questions. What is the amenable size of plant-based nanoparticles?
Yeah.
Should I repeat? What is the amenable size of plant-based nanoparticles?
Ma'am, it depends basically on the modulating parameters, pH as well as temperature, right? And the working conditions. I mean, if the extraction is completely done, very smartly, oh yeah, then it should be between initially, I tell you, initially you will get 20 to 35 nanometers, right? Once you optimize, we come to 10 to 15, further optimized 5 to 10. It is matter of practice, ma'am.
Okay, thank you, sir. And so why can't we synthesize even size nanoparticles?
Pardon me, can you repeat the question?
The question is why we can't synthesize even size nanoparticles?
Look, basically it is based on crystal growth theory. Okay. It is a process. It doesn't happen in a jiffy. It is a process of subsequence. One phase is getting transformed from micro to nano. Some is on the interface, right? Some is getting transformed at the threshold of getting transformed from micro to nano. So this is a process of subsequence. And the thing is, energy keeps on fluctuating. That is the beauty of thermodynamics, right? We have even sized cubic base, BCC structure, FCC structure, spherical structures. It depends upon the availability of energy. A person from physics will be better, answering your question. But as a biochemist, bio-nanotechnologist, I have limitations, I must admit. The thing is availability of energy. That is the crux of everything which I discussed.
The next question is, how does tropomyosin help in production of nanoparticles?
Yes, that's right. Collagen and tropomyosins are the very rich molecules, very least studied molecules, unfortunately. Collagen, in terms of thermodynamics, I must tell you, Well, we have done a lot of chemistry, we have done a lot of biochemistry, but in terms of thermodynamics, tropomyosin is the molecule which ensures our existence, because it is tropomyosin due to which this peristalsis takes place inside our system, right? So you can understand the degree of energy in folding and for unfolding procedures, ma'am. Once you open up the chain of the molecule, it gives you tremendous amount of energy in the incubation medium, right? So you get beautiful monodispersity of materials, whether it is a metal, whether it is an oxide, whether it is a chalcognite or the quantum dot. Similar is the case of collagen. Okay, you got the answer? Any further question, ma'am?
Yes, sir. We have 2-3 more questions.
Yeah, please do. Yeah. Most welcome.
Kaushal, you are not audible. Please unmute yourself.
Sorry, ma'am. Sir, can you elaborate more on the stability of nanoparticles?
Yeah, why not? Basically, plants or animal tissues or plants, or even very, very, very common example, I tell you, Kaushal ji, that, Milk Way. Do you know Milk Way? Milk Way, do you understand?
No, sir.
अरे यार, रसगुल्ला बनाने में जो पानी निकालते ना, वो दूध को फाड़ते ना।
Yes, sir.
दूध को नहीं फाड़ते ना, उसका कोगुलेट करते हैं ना बेटे।
Yes, sir. Yes, sir.
है ना, वो पानी जो होता है ना, दैट इज कॉल्ड मिल्क वे। ठीक है?
Yes, sir.
हाँ, वो बहुत रिच होता है बेटे उसमें, अमाइनो एसिड्स में, पॉलीपेप्टाइड्स में, है ना। तो वो तो बहुत अच्छा इनकैप्सुलेटिंग एजेंट है। जैसे ही नया बनेगा ना, एक तो नोबल मेटल है, बहुत स्लो ऑक्सीडाइज होता है, ठीक है, और उसको तुरंत इनकैप्सुलेट कर देता है। अब प्लांट सिस्टम की बात करो तो पेरेन्काइमा जो प्लांट सिस्टम का है, उसमें ढेर सारे प्रोटीन्स होते हैं, अमीनो एसिड सब में है, ऑर्गेनिक एसिड सब में है। ऑर्गेनिक एसिड ट्रांसफॉर्मेशन में मदद करता है, अमीनो एसिड इनकैप्सुलेट कर देता है, प्रोटीन जो है उसको इनकैप्सुलेट कर देता है, तो वो स्टेबल रह जाता है। ठीक है, यही चीज एनिमल में और ज्यादा हो जाती है। ठीक है, देखो एक चीज बता देता हूं मैं, वहां पर पॉलीफेनॉल्स अगर जहां भी ज्यादा होंगे ना, वहां प्रोटीन कम एग्जिस्ट करेगा। यही हमारी बायोकेमिस्ट्री कहती है भाई साहब, है ना। प्रोटीन और पॉलीफेनॉल्स का पुराना झगड़ा है, मगर इसमें अगर कोई नोबेल नैनो मटेरियल आपका है, जैसे कि गोल्ड है, सिल्वर है, प्लैटिनम है, तो उसको खूब आराम से प्रोटीन कैप्सुलेट करेगा और अपना फंक्शनल रहेगा, कोई दिक्कत नहीं। ठीक, any further questions please?
Yes, sir. Next question is, how long nanoparticles stay in our body?
काम चल रहा है। देखिए, जैसे कि अभी जितना ह्यू एंड क्राई हो रहा है ना, कौशल जी बोल रहे हैं आप?
Yes, sir.
हाँ, देखिए इतना ह्यू एंड क्राई हो रहा है अबाउट टॉक्सिसिटी इश्यूज एंड ऑल दैट। आज सदियों से हम बर्फ, मतलब वो जो काजू कतली पे ऊपर लगी हुई सिल्वर की फॉइल है, वो खा रहे हैं, ठीक ना, उससे टॉक्सिसिटी नहीं होती। जैसे ही नैनो एक नया टेक्नोलॉजी आया, तो लोगों ने उसके अगेंस्ट बोलना शुरू कर दिया। ठीक है भाई साहब, एक्चुअली सिल्वर जो है हमारे पूरे लाइफ साइकिल में 8 मिलीग्राम तक सिल्वर हम खा सकते हैं। ठीक है, या मैं शायद 8 ग्राम नहीं है, 8 मिलीग्राम है या कुछ ऐसा ही है, देख लीजिएगा। उससे कोई टॉक्सिसिटी नहीं है बेटे, खाली बॉडी में अर्गायरा हो जाता है, पूरा बाल वाल सब कुछ जो है ना सिल्वर कलर का हो जाता है। ठीक है, और इस पर अभी नैनोटॉक्सिकोलॉजी पे काम काफी चल रहा है और बड़ी ही कॉन्ट्राडिक्टरी है वो, है ना, बहुत कन्विंसिंग बेटे ऐसा आया नहीं है जो कि मैं उससे बहुत ज्यादा कन्विंस्ड हो सके। हाँ, बताइए आगे। नाउ
Okay, so next question is, as a beginner, which method can be used for synthesis of nanoparticles?
सॉफ्ट केमिकल ले लो। सॉफ्ट केमिकल नहीं, बच्चे हो अभी, किस क्लास में पढ़ते हैं आप? एमएससी में हैं? You are a student of MSc?
He's a BSc Honors Biochemistry student, and
Okay,
as a representative, he's asking questions which are posted by the participants in the chat box.
Okay, no problem. You can take anything. You can take yogurt whey. दही का जो पानी होता है कौशल, yogurt whey, you just mash the yogurt, in a mixie and filter it or centrifuge it, you get the supernatant, right? That is the way. You dilute
Yes, sir.
it twice. You dilute it twice and then modulate the pH. If you want oxide, bring it towards acidic side below 6, 7, below 7 बेटे 6 तक रखो, है ना? अगर तुम्हें मेटल चाहिए 7 से ऊपर ले जाओ, 8 तक ले जाओ. कैसे ले जाओगे? सोडियम बाइकार्बोनेट डालो, हल्के 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 पीएच सेट कर लो. अब तुम्हें ऑक्साइड चाहिए तो जिंक क्लोराइड डालो, खड़ाक से ऑक्साइड बनेगा. अगर मेटल चाहिए तो सिल्वर नाइट्रेट डालिए, आप तुरंत सिल्वर बनेगा. सबसे आसान तो वही मुझे लग रहा है. वैसे कोई भी पौधे का एक्सट्रैक्ट ले लो, टेक एनी प्लांट एक्सट्रैक्ट, एनी प्लांट extract, and then you will get nano silver. So nothing to worry about it.
Okay, sir.
Okay. Any further, please?
Good evening. This is Dilshad Begum from Chennai, from the Department of Zoology. Sir, actually, from animals, particularly, you said that Periplaneta americana, that is from cockroach, you have extracted. So, what is the role of this chitin, sir, in synthesis of this nanoparticle? Role of the chitin, because when you are,
you complete your question, ma'am. First, yeah,
that's what, sir. I just want to know how good from the chitin we can synthesize the nanoparticles.
It is not only chitin, ma'am. It is also tropomyosin in that. Chitin is one of the materials. Well, of course, the core material of the integument. But you can, if you go to the chemistry of acetyl glucosamine, it has a beauty of getting modulated in a structure in response to temperature and pH. And by liberating the free energy, you can get a material of your choice. And then for further help, you have metallothionein, you have tropomyosin.
Yes, sir.
Yeah. You go to chemistry. I mean, we have papers and you go through. I mean, that is on the Google Scholar. You can download and go through it. It's an old work, 2013. Yeah.
Thank you. Thank you so much, sir. Thank you.
Pleasure, ma'am.
I think with no more questions, I extend heartfelt thanks to Dr. Anil Kancha for taking out time from his busy schedule to be a part of this workshop. I'm sure your talk must have enthralled one and all. It very well covered the beginning of the nanotechnology by Richard Feynman to Professor C.N.R. Rao in India, how plants made into nanoparticles can be synthesized. Your products ranging from masks, lotions, sprays, they look quite promising. We all look forward to meeting you in person in the college premises post-corona. Sir, and thank you all the participants for joining us today. We look forward to meeting you tomorrow as well.
Okay, thank you. It was my pleasure. Thank you. Thank you, ma'am. My gratitude to you all. My best regards.
Thank you, sir. Thank you.
Thank you.
Thank you, sir.
Thank you.
Thank you so much, sir.
Thank you, sir.
Thank you. Thank you.
Thank you, sir. And thank you for the organizers also. Thank you so much.
Thank you. It's my
Thank you,
pleasure.
thank you.
Thank you, Abhijit.
Thank you, sir. Thank
I
you,
hope you liked the talk.
Yes, sir. I like it.
There were about 120 participants.
Right.
I hope you enjoyed the talk, but time was limited.
Very
I had to go
interesting.
fast, and the power is just coming and going. It was a challenge. My laptop also cheated me on the particular moment, so I'm.
No,
It's okay, sir.
not very well.
It is a loan from my son. This laptop is my son's laptop.
These are technical glitches which can't be avoided in today's world. So we all are facing them today or tomorrow.
Yeah. I hope you all liked it. It was my privilege.
Yes.
I'm really honored, and it is a memorable day of my life. Thank you.
Thank you so much,
Thank you,
To
sir.
you all. Thank you.
very
Thank
much.
you, Shivaji College. Thank you all.
Thank you, sir.
Thank
Thank you,
you.
sir.
Thank you so
Bye.
much.
Take care.
Thank you so much.
Bye.
Thank you so
Bye.
much.